Hello and welcome everybody. My name is Nigel Blandford and I'm from the University of Salford Energy House 2 team. And welcome to the first of 4 sessions on this smart homes ecosystem. So this whole series of webinars will be about smart homes, but there is, I will say right at the beginning, a bias on energy. But the concepts and the skills that you'll see here can be used across the smart homes ecosystem, not just the energy side. But our concentration on energy is for 2 reasons. One, it's sort of our background, I guess, and secondly, it's home energy savings are a financial incentive for everybody. So basically, at the Energy House 2 programme, which is assisted by the European Regional Development Fund, we're here to assist Greater Manchester small and medium-sized enterprises. For those of you that are outside of Greater Manchester, you have them to thank for these sessions. Having attended these webinars, these Greater Manchester small and medium-sized enterprises will be in the position to potentially access our facilities to research and test their products that they might be developing at zero cost. Other companies are welcome to have their products tested by us, but this will have to be on a commercial basis. So just a few house rules. You've all been placed on mute. So that's the first thing. There will be questions and answers at the end of each session. So that's not during, but towards the end of each session. And these will take place via a text facility within your screen. So if you look up that direction, I think to the top right hand side, you'll see a little button with a question mark there. You can submit a question to us at the end of each speaker's session there, and we will endeavour to get round to answer them. If there's too many, we might not be able to do all the questions. We have allowed a generous time for questions and answers after each percentage sessions, but if they aren't fully used, we will just advance the programme. So this may result in sessions finishing earlier than 3:30. Each day around the midpoint, there will be a 15-minute comfort break, and we have set up several separately named meeting rooms. Here you can meet your fellow participants. And that's for during the comfort break or during the whole of this session and slightly after the session. We won't call you back in after the comfort break, so it's up to you to rejoin the formal seminar in Teams Live here, and you may need to log back in again if you've logged out. Please be patient with us. This is our first attempt at a webinar, so there might be a few hiccups. We hope that by the last session all these teething problems will have been ironed out. And on the plus side, I don't need to talk to you about what we normally do about the fire procedures, so no need to talk about that, or where the toilets are, because you know where they are, or to put your phones on mute. We are hoping to record these sessions and make them available, but these recordings might not be available for several weeks after the event. We'll try and get them done as soon as possible. Throughout these 4 sessions, there will be something that you gain. They are pitched so that even if some of the subjects are outside your technical understanding, you will understand the concepts which can be applied to your specific field of knowledge. So finally, just to say that I'm merely a research assistant at the University of Salford, and to give you a proper welcome to Energy House 2, here is Professor Will Swan. Thank you.
Good morning. My name is Professor Will Swan and I'm the Director of Energy House Labs, and I just want to welcome you quickly to this Smart Homes webinar. Recently, things have been changing in the domestic energy sector. The smart homes infrastructure, electric vehicles, batteries, renewables are all working together in different ways. We see there is an awful lot of opportunities in this space, which is why we've put this series together. So before we get into the meat of the day, let's go and have a look at some of the things that some of our colleagues are doing in this space.
Hi, my name is Dr. Richard Fitton. I run the Energy House test facility here at the University of Salford. So we stood outside the building now. So this is the Energy House. So we have a Victorian terrace building, number 1, number 3, which are very run-of-the-mill types of buildings. So this is a solid wall. It has no cavity, no insulation, just a thin layer of insulation in the loft, and it's got suspended timber floor, and it's fitted with single glazed windows at the moment. So The difference about this place is it's in a huge environmental chamber. So we can take the temperature down to -12 and up to +30. We can make it wind, rain, snow. We can put solar radiation on the building. So that allows us to carry out lots of experiments where we control the climate on the building itself. So a typical use of this would be to put a set of heating controls in there, run a standard occupancy pattern, and then change the weather. So we can look at how the controls perform in spring, how they perform in the winter, and maybe how they perform in the autumn and the summer as well. So that allows us to take very detailed and accurate measurements of the performance of the building. And we can do the same with things like solid wall insulation, double glazed windows, and different boiler installations in there as well. So basically anything that we like to change on the building, we can. So we've done work with Saint-Gobain, who are a large product manufacturer in the construction industry, looking at various different ways to insulate the building. We've done lots of work with boiler manufacturers, different ways to heat the building, and also things around very straightforward energy savings devices such as curtains and carpets, and the difference that those devices can have on the thermal comfort and the energy savings in the building as well. So in essence, it's a very physics-based approach to how we measure the performance of buildings. So we work side by side with our smart meters lab and our thermal measurement laboratory to bring new products in and to measure them in different ways as well. So there's a significant issue here, is that we only have one building and one chamber. So this building is currently booked up for the next 12 to 18 months, solid with work. So we needed to make a step change, and the step change that we're going to make is Energy House 2, which I'll talk to you about next.
So this is just dispersing some myths here. You can see in the background we're in Manchester, it's not raining, and there's even a bit of blue sky over there. And we're also going to disperse a other few sort of misconceptions that you might have as well. You've seen that lovely 3D visualization of what the energy houses look like, but some of you out there are probably thinking, well, yeah, it's all right, it's on a computer, this thing actually isn't happening. Well, I hate to tell you, but you're wrong, because it is happening. You can see here behind me, this is the Energy House, Energy House 2, and we're just about the beginning of March now, so you can see it's flying up and it should be ready at the end of this year.
Hi, I'm Ioannis and I'm running the Smart Meter Smart Homes Lab. Together with Nigel, we have organized and running this workshop. We have prepared a couple of videos to talk about the Smart Meter Lab. Hope you enjoy the workshop. Thank you very much.
Hi, my name's Nigel Blandford from the University of Salford Energy House team, and I'm going to talk to you today about the Smart Homes Smart Meters Labs. This is the campus here, and as you can see, it's readily expanding. But the Smart Meters and Smart Homes Labs is over that way. So let's go and see the Smart Homes Smart Meters Lab. Welcome to Dual House, which is the home of the Smart Homes Smart Meters Laboratory. Now you may think Dual House, obviously it's something to do with energy, but there's actually a surprise here. This was actually where James Prescott Joule lived. So let's go inside and have a look. This is the man himself, James Prescott Joule, who lived in this house. He was the son of a brewer, but he's also done his experiments in this very house. And if we walk over here, you can see a representation of some of the equipment that he used, which was then went on to form the basis of the first law of thermodynamics. And this is the smart kitchen of the Smart Homes Lab, but it's also in Dual House. It's actually our own working kitchen as well, so we get to use it and see it in operation every day. So if you come in and have a look in here, we do monitoring here. So if you look at all these sockets here, all these red ones, these are all individually monitored, so we can tell the power consumption coming out of each individual socket in here. Plus we have Alexa control in here, and if we look around here as well, you can see that we have some smart sensors and interpretation on here as well. All the devices like the dishwasher and the tumble dryer here are be able to connect remotely to Wi-Fi. And if we look around here, the piece de resistance is the fridge. And if you have a look, the fridge here has a camera in there. So if you're popping out to the shops and you don't know whether you've got your milk or not, you can look in there. And also being an academic's fridge, there's probably lots of out-of-date food in there as well. Welcome to the Smart Homes living room. In here, everything is connected and highly monitored. The heating is on a different circuit, the lighting and the power is on a different circuit. And we have here smart televisions, smart devices, again with the interpretation around. We even had at my feet the smart robotic vacuum cleaner. And this is all monitored from our control room, the heart of the Smart Homes Smart Meters Labs, which we'll see next. And this is the control room for the whole of the Smart Homes Lab, the Smart Meters Lab. And you can see over here, we have a range of smart meters with isolators. We can bring each one in online to check individual meters and their functionality. And over to the other side, we have the gas meters. And we have this controlled circuit within the building. So the living room and the kitchen are individually monitored on different circuits here. We also have other devices like the consumer access devices here for monitoring the electricity consumption from the smart meters in a finer detail. And if we move over here as well, what we have connected in here, we like to try and stress the system. So we have connected as well, not only a gas boiler outside, we have a heat pump in here, so we can see the interactions of a heat pump within the smart homes. And outside we have some solar panels and electric vehicle chargers as well. And we will look at electric vehicle chargers in a bit more detail. This is another one of our facilities. The electric vehicle will become part of everybody's home in years to come. So that here, at this test facility, we can look at taking the electricity from the vehicle back into the home or into the grid, and using what impact solar panels will have as well on the charging.
My name is Ioannis Paraskevas, and I would like to introduce you to the Smart Meter Smart Home Research and Innovation Lab. The Smart Meter Lab organized and runs this workshop, so I would like to say a few things about the lab, how it started, its aims and objectives, examples of past and ongoing projects, and close with a very brief overview of the workshop. The Smart Meter Lab is located in Jewel House, which is a Grade 2 listed building, and more importantly, it was the house of James Joule, where he created the unit of energy. The Smart Meter Lab was originally part of the Energy House 1 lab. However, it was launched as an independent lab in December 2018. The primary scope of the lab is to engage with industry and to conduct research, development, and test on energy and cost-saving solutions and technologies. In our project, we are utilizing data from the smart electricity and gas meters, as well as data from a variety of smart devices using API technology. In terms of its infrastructure, the Smart Meter Lab has very strong links with the industry. So we have most, if not all, of SMETS 1 and SMETS 2 electricity and gas meters. The Smart Meter Lab is organized in 3 rooms. One room is the control room, and the other 2 rooms is the smart kitchen and the smart living room, where we have a variety of smart devices. Here are a few photos from the smart kitchen and the smart living room. The Smart Meter Lab provides a unique opportunity for innovation around software as well as hardware, and provides a test bed in a safe and secure environment. A couple of examples, a few examples of past and ongoing projects are presented here. In the past, we worked with a company which developed an optimization algorithm which matched time of use tariffs with the operation of an air source heat pump. Currently, we are working with a cybersecurity company which conducts penetration tests in the lab in order to test the immunity of the smart home ecosystem. Also have worked with EV charging companies, and also we have helped companies to access smart metering data, electricity and gas smart metering data, in order to incorporate this data in their software products. There are a lot of companies, bigger and smaller, which support the Smart Meter Lab. Example of these companies is Schneider Electric, Octopus Energy, Hildebrand, Wonderwall Energy, Chameleon, Trillian, to mention just a few of them. The workshop, the Smart Energy workshop, is organized in 3 sessions, I would say. The first session focuses on the first day on the introduction to the IoT and to the domestic smart metering infrastructure. The second and third day focuses on accessing and utilizing smart metering data for energy and cost saving. And then the last day, the 4th day, focuses on home energy management systems, known as HEMS. And it will be also a very interesting presentation on the cybersecurity aspect of the smart home ecosystem. Thank you very much.
Hi, it's Nigel Blandford back again live. Usually if we were doing these sessions face-to-face, we'll have a sort of round the table introduction, but we obviously can't do that. And because of the nature of this current platform, it's going to be very difficult. So there will be the opportunity in a little while and a comfort break to go into separate rooms, and you can introduce yourselves there, but I'll just give a quick run through of everyone that signed up for this event, so you've got an idea. So the people from the Greater Manchester, the premier group of small and medium-sized enterprises, we have Overland Technology, Izan Innovations Limited, Indictura Limited, DRH Amra Consultants Limited, S-Meter Research, Veridan Consulting Engineers, Silverfrost Limited, AMLA Consulting Services, JSA Software Systems Limited, Everywhere Apps Limited, Sustainable, the Othello Partnership, IoT Horizon Limited, Lucid.Home, Snow Solutions Limited, RCP Services Limited, Evergreen Energy, Eco Homes Upgrade Limited, JSC Software Systems. So they're our sort of star premier line as small and medium-sized enterprise from Greater Manchester. We've also got some sort of larger or other companies from Greater Manchester and organisations. So we've got Wigan Council, Trafford Council, representatives from Smart DCC. They are talking later, but they do have offices in Greater Manchester, and Calvin Capital. Across the rest of the UK, we have My Energy Ratings Limited, John Francis MEP Limited, Reactive Energy, Larkfleet Smart Homes, JTech Ventures CIC, JF MEP, Any Offsite, STH, Wadebridge Renewable Energy Network, University of Exeter, GIST Jonah, Retrofit Support, Manx Utilities, Cotopaxi Limited, AECOM, Lee Howe Chartered Surveyors. So that's other companies from other parts of the UK, but we do have people from around the world here. This is an international audience. I'd just like to say hello to these people, welcome these organisations and companies. So we have the Industrial University of Santander, Colombia, PRFM from Turkey, Keller Williams from the USA, Sunriva Facilities from India, Building Physics South Africa from South Africa, PricewaterhouseCoopers from India, Re-Energia from Pakistan, Manipal Academy of Higher Education from Dubai, Intersection Energy Taiwan, Al-Kima from Saudi Arabia, Curtin University, Innovature from India, WSD Hong Kong, Disruptive Creations Canada, from Beirut we have Metax Sao, from Mauritius we have Beer Group, and finally from Portugal, Axians. Thank you very much and welcome to all these people that are attending. Now we'll have a comfort break. So the comfort break usually runs for sort of 15-20 minutes. We'll run it today until 1:30. So we will start promptly back at 1:30. So that's just over half an hour's time. There will be a slide going up in a minute with 3 rooms on there. So these are 3 individual rooms. Pick one of those rooms. There's the URL on there. You can do audio or video. We've created the 3 rooms because I think if there's a lot of people all going into the same room, it's going to sound like a bit of a mess. So we'll put the slide up now. Yeah, that's great. Put the slide up there. You can see that there are the red room, the green room and the blue room. We will see you back promptly at 1:30. I'm not going to come round and kick you out of the rooms or anything. So we'll see you back here at 1:30. Thank you.
Good. How are you? Oh.
Ben, can I talk to Nigel or we? Ben, hi. I cannot hear you.
You okay, Yanis?
Yeah.
Hello, everybody, and welcome back. I hope you had a good chat in the little rooms there, and I will make sure that by tomorrow I will email everyone and put those URLs in for the comfort break rooms in a link, so you don't have to type them out manually. I must apologise for that. Okay, so you've seen us University Sorts tell you all about what we're up to, but now it's the real sort of the meat of the session here. So the first person that we have up today is Mike Mckean. So a little bit about Mike. Mike is a former Royal Corps of Signals technician, where his focus was on large radio systems. His current day job is a senior sales executive for Eurotech, who are an IoT gateway manufacturer. Mike is also chair of the IoT committee at the IET. Separate to the IET, he is involved with the UK MOD. In that second role, he advises the UK MOD Defence Science and Technology Sapient Panel regarding the use of IoT technology in the military environment. He organises two different meetup groups. One has a focus on AWS and the other on Node Red. He maintains his knowledge by designing and building IoT type technology. Mike is a generalist in terms of this technology. So without further ado, we'll go over to Mike's session. Thank you.
Hello, my name's Mike Mckean. I want to begin first by explaining what the Institution of Engineering and Technology is and what the IoT Technical Network is. So the Institution of Engineering and Technology is an engineering body of 168,000 professionally qualified engineers globally. We tend not to be IT managers. We tend to be involved in academia or research and development or manufacturing of engineering technology. So with 168,000 members, they each pay between about £200 a year or £300 a year to be members, and we get involved in advising governments and large organisations on technologies, and we do that via focus groups, or the correct term we have is technical networks. One of those networks is the Internet of Things, and I'm the chairperson of that network. So let's look at what the IoT is. So I'm going to start on the left, and this is what I'm going to, although I'm going to do a general introduction to the IoT, this sort of lays out the flow of data in a smart homes, smart meters type environment. And I'm going to include a couple of terms here that you might hear in the IoT world. So this might be a thermometer, it's a sensor, but you might hear the term publisher because it's publishing data. And again, this might be a meter that's measuring the use of electricity in an environment. And again, it's a sensor that publishes, or it's called a publisher, and it publishes data. And you'll connect to some sort of concentrator. So in the wired M-bus world, these devices get their power over a pair of two wires from the remote concentrator or the router type device, depending on what it's called. Or it's not a true router, that's what you might hear that term, or an IoT gateway, and it gets its power from here, and the data flows left to right, and that data is then packaged up and sent into the cloud. I'm going to just go into this in a little bit more detail for a second or two. So, by the way, I'm going to use terminology that might be relevant or thought relevant to AWS and or something called MQTT. There's different technologies, and by the way, I'm not affiliated in any way with AWS. However, MQTT is a messaging standard that's used. It's probably the most popular one in the IoT world. So as I use terminology, these terms, forgive me please. It's a general, although this is for a smart homes presentation, some of the terms I will use might be Amazon specific or might refer to MQTT. So in a IoT world, the data comes in from the sensor to this concentrating device. And remember, I might be connecting here in a smart homes environment to 5 or up to 250 devices on one wired network, one wired M-bus. And these devices are getting their power from here, but sending the data back to the concentrator. And let's say it's a block of flats. If I'm going to send the data back to this cloud, I need to identify that block of flats. So this will say I'm getting data in from these sensors, and the block of flats is reference 1234. And how does it pass the data back? What it does is it gives that message a topic, and that topic is 1234. So the cloud now knows that this data that's coming in is topic 1234, which means it's this block of flats 1234, and the data is associated to those flats. This data routing engine or broker routes the data because it says, this is for block of flats 1234, and routes to the database. It's then stored in non-volatile storage to be retained for X length of time, and then displayed on the website as block of flats 1234, or narrowed down to flat 15 and block of flats 1234. So generally, the flow of data is left to right, and in the smart homes world, typically you can do some minimal configuration changes. So you might want to change some of the settings on these devices remotely. That's typically how these operate. And what you'll find out in other environments, such as an industrial world or medical world or military world, the flow of data can be two ways, and you can actually send commands to these devices. So what also happens in the MBus world, the MBus world or the smart homes world, is that this device here polls these devices at a regular period. It might be every 15 minutes or hour or half a day, and says, send me the data, send me the data. What happens though in other environments is that if these gauges are measuring information about an engine, or if it's in the medical world, someone's health, what might happen is, certainly in the industrial world or the military world, it might say, I've seen something, I've registered something, and the application, or this gateway might say to another sensor, do something. So for instance, if something's registering there's a fire somewhere, then what can happen is that this environment here can send a message to a sensor saying switch the sprinklers on. Or if the engine temperature and pressures, if the temperature is going up and the pressure is going down, that's a characteristic of an engine fire. And then this device here will say switch the engine off and send an alert back to the back end saying there's been a problem with this remote engine. So although in smart homes the data is largely one way, you'll find in the wider IoT world it's much more two-way, and you have to architect your environment for that. And that's relevant to you, because if you're working now in smart homes, what happens when you start working with customers who are in an industrial environment or smart cities where you're controlling traffic lights, etc., or pollution, then data goes two ways. So think smart homes now, but think in a smart home block of flats, you might have a power generator outside that's providing backup power or something that needs information flow two ways. And you won't be using MBus then, it'll be something like Modbus. I'll come on to that in a minute. So let's look at the Modbus, let's look at the sensors gateways in a little bit more detail. So go back here for a minute. Remember, you have a method of connecting that might be by cable or wires, or it might be via radio airwaves. The important thing is you have to make sure that these two devices can communicate or talk with each other. You have to make sure the protocols are compatible. So in the smart homes world, very likely to be MBus or Mutabus being the same thing, using a pair of wires, or it might be the wireless version of MBus. But in industrial world, almost certainly not going to be those. It's going to be something like Modbus, and there's a couple of versions of that. Modbus was invented by Mckean in 1979, and then donated to the open source community, and it's since been bought by Schneider Electric, but still by far, I would say, well, by far, I shouldn't really say that. Modbus is a very, very popular industrial protocol, and there's some serial versions, RS-485, RTU or ASCII, or the Ethernet version is TCP. Something called HART 4/20, so it still works over a pair of wires, and the analog version uses 4 milliamps, means it's a minimal reading, i.e. HART is used in often in oil and gas environments, in oil fields, etc. So 4 milliamps might be a reading for a gas tank saying that it's a small amount of gas in that tank. 20 milliamps, for instance, might mean it's full, and it's graduated, calibrated in between at the gateway end to say, okay, it's 20 milliamps, the tank's full, for instance. And that works over a pair of wires. The pulse frequency is quite clever. It's also from HART. And what that does is it says, oh, I've wired up 1,000 sensors across a large oil field. You can reuse those same pair of wires without disconnecting anything. And it uses pulse frequency at 1.2 kilohertz and 2.4 kilohertz. 1.2 I think is a logic 1 and 2.4 is logic 0, or other way around. And it means that you can have sensors installed by company A using the analog version, and if you're involved in installation of products, you know that one of the biggest costs and biggest disruption and problems for health and safety is pulling cables. Well, you don't have to. You can say I can use the same pair of wires, and you can parallel off the sensors. You can say, okay, I've got my already installed analog network and sensors. I'll put some digital ones on from a different manufacturer, and they don't interfere with each other. That's really, really good. What's DNP3? Let me go back to this diagram here. Remember I said that this device polls these sensors, and it might do that, let's say, every 10 minutes. So imagine you're now a water authority and you've got 20,000 sensors, and that's a typical number. And they're measuring things such as the water flow or the water pressure. And you're going to poll these 20,000 sensors every 10 minutes, let's say, because that's sufficient to give you the trend of usage, etc., what's happening in environment. But what if you get a bust pipe? What if a pipe busts? You know, can you wait 10 minutes? That water flows everywhere. So with the aforementioned M-bus and Modbus, this polls these devices at a pre-agreed time, i.e. every 10 minutes. However, DNP3 is slightly different. It allows this sensor to raise an alert and say, I've got a problem. So it can raise that immediately and say there's a problem here, and then it tells the gateway what the problem is and says water leak at this location. So DNP3 is often used in utilities, and BACnet is used in the buildings, in the building environment, etc. And there's many more protocols. I wanted to mention this because you have to be really careful when you're looking at different environments. And okay, most things you're looking at, if you're looking at smart homes, then you'll be looking at things like M-bus or meter bus. But you might start looking at, you might get involved in industrial projects because you've been fortunate that you've started working on a smart homes environment. You get involved in something more industrial. What I'm coming to is be careful, be ultra cautious. So I mentioned before that there's something called HART 4/20 milliamps. And if you glance down, so the A, B, C, D, E, F, G are different ordering numbers. So if you, this is measures flow, pressure, etc. in oil and gas environment, and this measures the condition of oil. So when you're measuring oil condition, you're not talking about oil pressure or oil temperature. It's actually the chemical status, chemical status of the oil. That sensor on the right can cost like £1,200. And let me tell you why that's important. Rather than just changing oil because you've running the machine for so many hours or so many days or so many revolutions, you're saying if you change oil too quickly, too often, and too regularly, you lose money. If you don't change it often enough, then the engine breaks and you've got a bigger problem. So what they do is install an oil condition sensor that says the oil is in this state, please change the oil in the next 2 months or something. Right. The important point I wanted to raise was, look, that says 4/20 milliamps, and that says 4/20 milliamps, but that says HART. That doesn't say HART. They might work. Just be really careful. Make sure you really check. And other things check, you know, things like, you know, in the M-bus world, you get power, or you should get power from the. So just to remind us all, in the M-bus world, the correct thing to do is get power from this gateway, not anywhere else. And let me tell you why that's important. If you've got several hundred devices here in the smart homes world, then one thing you need to be really careful of is that's a shared bus. If you get any noise on one sensor, you share that noise with. If you've got 250 devices and you've got noise coming from one device, that noise is shared across all the devices. So one of the things you might have is something called ground loop or earth loop. Look it up, and look up in Google. What it basically means is that one of your devices is acting as a transmitter and using the cable as an aerial to transmit noise down that bus. And if you, let's say, here's a typical problem. You're doing a project and you're installing 250 sensors in a big block of flats, and you go and install them all, and then you switch on your device here, and you've got coming down your. Does that a good impression? You got humming coming down that line. That's a problem. The safe way is to install the gateway and install these. Yeah, install them all up, but on your patch panel, connect one at a time, and just then check for noise, etc. And hopefully you haven't got any noise. But if you have got noise, typically it's what's called a ground loop or an earth loop, because one of these devices is humming. Right, back to where we were. So make sure that your devices are compatible, and be very, very careful how you connect them up. And I always suggest doing some sort of test. Right, so moving on again. So this is our environment. Refresh us. So we've got our sensors publishing data through to the gateway or concentrator into the cloud. But remember what I said here? Sensors, publishers, make sure you get everything right, make sure you're careful about everything. I know I'm being very detailed about this, but it's really important that you, if you're managing a team to install these, or you're designing an environment, it's really careful to make sure you get this right. So I also run a couple technology meetup groups, one's for AWS and one's for Node-RED, that's a programming environment. And one of the things I do is I do some live demonstrations, and it's really, I want to show now how important it is to document things. This is an industrial thermometer which works at IP65. IP65 means that basically I can blast that with water or with dust or gas, and it doesn't ingress any contamination into this environment. And inside here is a little circuit board. Remember I said you get different types of Modbus? So this one boots up in what's called Modbus ASCII, and I wanted Modbus RTU. So I have to change the jumper. And here, because it's RS485, you have to balance the line with 120 ohm resistor to make sure you don't have impedance mismatches. If you have impedance mismatches on your line, then you'll get noise and it won't work correctly. And you can have, like MBus, you can have hundreds of these devices on a network. And I'm nauseous about detail. If I've got people building this for me, or I come back to 6 months later, I want to remember what I did and how it works. Right, so think now, again, this is the wider IoT world. If you're just doing MBus, just keep it dead simple, that's fine. But if you start working on the other environments, think about the physical connectivity, wireless. I do work with medical and military as well. Data security is important. Data throughput and costs. If you're working in smart cities type environment, what you'll have, and you can get involved in sensors from traffic lights, etc., and you've got a SIM card, a little modem on your remote devices. You think about the cost of all that. If your customer says, I want this SLA, that's fine. But if you then need to start increasing the data throughput, then you might raise the costs of the SIM cards costs. Depends who's paying that, but think about that. Think about connecting to this concentrator. Think about your connectivity, your medium, your error checking, the costs, etc. Make sure that this device has an open type architecture. I mentioned before, let's just go down here for 1 minute. I mentioned before smart homes, so that's the environment you're thinking of here, but what if you get involved in smart cities with a local authority? Then there's something called LoRaWAN you'll hear about. And what is LoRaWAN? LoRaWAN is where you have a radio transceiver here, and these are LoRaWAN type sensors rather than BM-bus. And what happens is LoRaWAN is an environment that is switched on 24 hours a day and is free to use. But hold on, I'm going to tell you something different in a minute. And what LoRaWAN does is it says, send me your data. And it's typically very much like a smart homes environment, very, very small packets of data. And typically you want to update the data infrequently. So it might be in what's called smart agriculture, where it's what's happening in terms of temperature or water or humidity somewhere, and you're sending data back to concentrator maybe twice a day, and that's sent to the back end. Right, so that's LoRa. That's the LoRa transceiver that send receive data, and these are the remote sensors in a normal way, and that would be your back-end application. Let me tell you why I'm explaining that. People think that they can build their own environment here. So if I'm a local authority and I'm looking at smart city environment and I've got smart homes environment here, let's say I've got 10,000 smart homes types devices, and say, I think I'll lay cable to all of those 10,000 devices, and I will just communicate with everything on LoRa, because LoRa is free to use, and I'll cable out everything for 10,000 sites. It costs me a lot of money, but I'm going to do it anyway, because everything's free after that. It's not free. It's not 24 hours a day. So here's the URL here. So if I was in that local authority and I'm saying I'm going to build out my own network, I'm going to build it all out and lay cables everywhere, you're still using the public airwaves for your signals. There's I think there's 8 different channels you can use. One of them allows you to be online 14.4 minutes a day. Another one's 1.4 minutes a day, and that's okay. As if you're in a smart homes environment and all you want to do is take readings, a couple times an hour or something, then that's probably all okay. There's more to it than that. You also got to do what's called pseudo-random frequency hopping, so you don't hog channels all the time, but that's okay if you build that environment. So if you're going to spend 5 or 10 or 20 million pounds building your own network, then you can be online legally for up to 14 minutes a day per sensor. But there's another environment. So again, I'm not affiliated with the Things Network, but it's a very popular public environment. And there, if I go back here for a minute, then basically the Things Network supplies all of that. And what that really is people who buy their own gateway, plug it into the home network and say, hi, I've got a gateway you can use if you want. But if you've bought that, do you want people hogging the bandwidth all day? You don't. But so the Things Network is a network of, I'm going to call them hobbyists. That's a little bit unfair, but it's not where you've bought your own network, but hey, you've not spent 10 million pounds. So then you're using the Things Network, and here's what they say. Here's what the Things Network say is 30 seconds a day. And that, again, that's fine. If all you're doing is accessing LoRa types sensors to send messages, a handful of times a day, then that is fine. So as you're moving around in this environment and hear people talking about LoRaWAN, then just make them aware, ask them to do a Google search on availability of these environments, because people actually deploy, because LoRa can work 5 to 20. If you're in a desert environment, it could work maybe 20 kilometers or long or further, and you say, well, there's no one around here, I'll just hog the bandwidth all day for 24 hours a day. But what if someone else opens up next to you with their environment and complains? Then you've got a problem. Right, so we're back to this reminder here of what we're talking about on the environment. And I've got a reason for this, and I'll explain on the next slide. So sensors, data flows all the way through, and you've got to manage all of this as well. Managing that environment. Let's go back here for a second. Now let's think about your environment. Let's think about smart homes. You got a remote concentrator in a block of flats. Where's that going to go? It's going to be in somewhere it's not easy for the public to get to and vandalize or get broken, but it's got to be accessible. Tends to be in a closet out the way, tends to be in a roof void somewhere, etc. And the same with these. They're typically somewhere where they're not often accessed. Here's something. I was working on a large project, and a customer wanted to work with me. So think smart cities. This is a company that's very popular in utilities in Europe, very, very popular. And the customer said to me, Mike, I want to work with you, but I'm sorry, this other company is slightly cheaper and their website is absolutely brilliant. And he said, is there any way you can find a fault with or problems with their environment? And then we'll place order with my employer. And I'm relatively technical, so I looked at their technical manuals, and I actually checked this for another presentation in November 2020, and it's still up. It was still the case then. But the important thing is that to update these gateways, you can see they've got a Wi-Fi or a cellular type antenna, so they can send data back to the network. But if you want to update them, Mr. Engineer goes outside, goes there with his coveralls on and his Wellington boots, and presses a magnet up against them to erase them. And then I guess he sits with his laptop or something and programs them or updates them, etc. But what I'm saying is, if you're in the smart homes environment, think about updating your devices. What happens if they go faulty? Think about the gateways, the concentrators, how do you replace them? And utilities, health and safety, think smart homes, think blocks of flats, doing projects for local authorities. Then health and safety, it's 2 men and a ladder. You know, a simple change just costs you £500. So think about remotely managing devices. Think about what's called over-the-air upgrades. There's something missing here, and I'll come on to that in a minute and explain why. Here it is. So I know I'm labouring it probably. Oh, I'm sure I am. It's just where I see all the problems, because the people at the back end think that what they want here at the back end is an application on their phone. What they're forgetting here is that this end, you know, if you can't connect or you've got problems or you have to change things, then this is where the real costs are. You know, it's where the problems are getting the sensors installed in the right sensors. So think about your field protocols, think about your connectivity. This device is key, really is key, because it connects this end, the field end, to the back end. These are typically, now I'm talking now about more general IoT. I'm not talking specifically now about smart homes, and that's important because if you're working in a block of flats and there's equipment there that are managing the elevators, the lifts, or some sort of power environment or building management systems, they might well be using something else such as BACnet or Modbus or something else. And if you don't understand that, you lose credibility. On the positive side, if you do understand it, you might win more business. So what I'm coming to here is this sort of gateway device will often be a small Linux server. It's the size of a large book. It's not huge. And it'll have what's called an edge compute environment, programming environment. Make sure if you're involved in that, either supplying them or getting involved with integrating with it, find out what the IDE integrated development environment. Find out what the environment is. Hopefully it's not proprietary, i.e. it's Java or C++ or something. And oops, sorry. If you're supplying these, think about the operating system. Go for Linux. I suggest Linux type environment, and the programming environment, open source type environment. JVM is really important because there's been a lot of changes in the JVM world recently, so make sure it's supported. And try and get an environment that's got a vibrant user group, because again, are you selling this for 1 year and walking away, or are you going to be supporting this for years? You know, if you've got a contract, a service contract in smart homes environment, smart cities environment, then who's going to be supporting it? Make sure this device is going to be supported by the manufacturer and user group for years to come. Same with the sensors. And then I showed you a picture before of the chat with the magnet. It's more just a magnet. These typically connect to vendor's cloud. I'll come on to that in a little minute. Think about how you connect to it via the vendor's cloud. That can be expensive, or via OpenVPN as an option. OTA upgrades is over-the-air upgrades. That's the magnet scenario. And then dual areas of RAM. What does that mean? So if this is running with operating system 1, and you want to not just do upgrades or patching, but you want to do a complete operating system upgrade, what you have to have is operating system 1 is running in the ROM, but you have to have enough RAM to store operating system 1 and operating system 2. Let me explain that. Let's say this is a 2 gig operating system. What you do is you download operating system 1 to area of RAM 1. You're still running on operating system 1, but you download a copy to RAM area 1, and you then download the new image to operating system to RAM area 2. You then mount operating system 2 into the device. If all goes well, great, that's how it runs. If it doesn't go well, you fall back to operating to the operating system 1 in RAM area 1. The important bit is you didn't try and do an upgrade and lose the device. It was intelligent enough to fall back to the other image. Right. What you'll find with these devices is that sometimes they're offered quite a competitive price, but they only connect to one cloud, and you'll then have to pay that cloud provider for the service charge. That's fine if you understand that and you know that and you want that, but what if you don't want that? What if your requirements change, or your partner's requirements change, or the company or the service starts to drop, the service levels start to drop from this cloud? You're locked in. So you can break that, you can break the image, and often you lose the warranty, but also you lose things. Typically use something called Trusted Platform Module 2 or TPM2. They try and lock you in with that. So what I suggest you do is get a device that can connect to multiple clouds simultaneously. As a watchword here, you'll often find different levels of functionality. That's just a matter of life from different cloud manufacturers with different devices. So typically what you have in some of these clouds is what's called twinning or shadowing, and what that is, it's not an image, it's a configuration. So if you've got 1,000 of these gateways in your cloud, you'll have 1,000 twins or shadows, and as you change these devices, the configuration of the devices, the configuration is changed here. What the benefit of that is, if this device had been in a situation for 2.5 years and it's had some changes made, and an engineer goes to change the device because it's faulty and installs a brand new one, what happens is this cloud will automatically upload the changed configuration, so it makes life a lot easier to manage it. How do you communicate from this device to the cloud or clouds? I've written here MQTTS and HTTPS. If you Google these, the easiest thing to do is what's called MQTT or HTTP. I prefer MQTT. If you've got 2 minutes and you're sitting at your laptop right now, let's do a quick search along the lines of which is faster, MQTT or HTTP, and you should find that MQTT is a lot more efficient. And importantly, all the big cloud manufacturers support both. So if this was Amazon and Azure or Google or IBM, whoever it is, then you find that they all support both these protocols. I think Azure also supports CoAP, I think, but MQTT and HTTP are the most popular. You'll find that something to be aware of if you're working with an environment, and one thing you could ask very gently of their engineers is, hello, do you use MQTT or HTTP? If they look at you blank regarding MQTT, then they're probably used to developing apps on games or shops. Let me tell you why that's a problem. Because in the HTTP world, or the commercial shop type world where you're developing online shops, the aim of the application is to make it sticky. You want humans to come to the website and be interested and have a long engagement and have a sticky environment. You don't want that on IoT. On IoT, you want the information to come in really quickly, connect, deconnect, connect, disconnect, connect, disconnect. You don't want long engagements here, okay? So the MQTT is specifically designed for what's called resource-constrained devices, so small gateways, and for transmitting small messages. And if in your world, in the in the M-bus world, smart homes world, you're sending very short messages, so you want an environment that is tailored to sending small messages. Right. Let's look at the cloud now. So we've talked quite a lot about the devices here. Let's look at the cloud now. And this could be on your premises or in AWS or Google or IBM, etc. And this is normal IT sort of things you would expect, but there's something else here. Remember I said the gateway. The gateway has also usually got a programming environment, and that's important because if you've got devices here and one of them raises an alert because there's a fire or something, or a temperature exceeding a temperature has exceeded a normal operating range, and that sends a message, or you poll it and the message is received by the gateway. If that connection here, if the LAN connection back into this environment or the cellular connection is down, then there can be raging fire here and no one knows about it. So what you also happen often is you'll install an application on the gateway that says, if my link is down, and if the sensor says there's a fire happening, then I'm going to switch on the sprinklers. And that's very important in the industrial world. You do that for lots of things in the military world, the medical world, and industrial world. Yes, you'll often, or you will send data back here, but you won't always rely on that 100%. You'll have a default that says if the link goes down, I'll also send a command out from here to a device to do something. Analytics. Think of your smart homes environment now. Where people are subscribing to a service and data is being published about that usage of electricity, etc., back through the concentrator to the back end here. What you need to do is not just publishing data all the way through. You need to be able to analyze that data. You need to be able to publish it in a way that's user-friendly. This might be to a utility or to a home user saying this is what's happening with your usage on with your home electricity. So design your system so that your data comes back to a database. It might have different database tables from different sources, but always think all the time about the end user. Who is the end user? Is it a utility? Is it a service company? Is it the customer? Is it the homeowner, etc.? Design it so the information, do they want data updates every day, every few hours? And that comes back to, are you publishing data via yes, if it's M-bus, etc., it's wires or wired M-bus to the concentrator, but how are you getting the data back to the back end? Keep thinking about that all the time, how you're going to do that. I mentioned before that various types of clouds. I personally use AWS quite a lot, and you might be thinking, oh, I don't, quite normally and quite obviously, people do not want to be locked into one particular cloud. So I'm going to use some terms here in the next slide. It's a little bit busy, but I'll go between the two. Here's the important part is that the things that are really complicated and difficult are the broker and the database table. And what I'm going to show you are several open source free solutions. I include the links to the websites. So data storage is disks. Generally that's not free, and your website usually is not free, but data storage you get from anywhere. That can be on your premises or somewhere else, and your website, wherever you get your websites from. But the clever parts are the broker and the database table, and I'm now going to show you some. I'll give you the links as well, the URLs to these websites, and these are in use by the largest companies in the world. So let's say, like me, you've built your environment in Amazon, and for some reason you want to move out of Amazon. Is that possible? Right. Let's go back here for a second. Remember, the main parts are the broker. Let's do the broker first, actually. So I've shown one broker here, but in this diagram I've shown two. Okay, and in the next slide I'll show you a whole, there's about, I don't know if there's 10 or 20 of them, but I've shown two. And remember, I said the gateway should be able to connect to one or more brokers simultaneously, and then you en route the data. So that could be a cluster of brokers for high resilience. Okay, so back here, that's the broker part. What about the database part? Here's your database part, and I'm suggesting it's a personal thing. And again, I'll show you a page with, I don't know, about 8 or 10 different free open source brokers, databases. I personally use MongoDB. So storage, get your storage whenever you want to. In terms of analytics, there's a free offering from Google Data Studio. So you've got your free brokers, your free database. Your storage is probably not free. You've got to buy the disk from somewhere, but you can analyze it using Google Data Studio. And then here I'm showing you've brought your environment back to your own premises, and then your application you'll have to write yourself, but you can bring your data in from other inputs as well, and then output to your website. Now, here's the two complex parts, the broker and the database, and I said there's some free options, and there are. So this is the, there's many more here, by the way. The page was too big. So here's the website. If you miss this, then email me, I'll send you the details afterwards. And it gives a list of free open source type brokers. And I mentioned Mosquito only because I happen to use it, that's all. Nothing, no more than that. And now on databases, or the one that, so this is a number of databases, and NoSQL. So there's two general types of architecture. There's more than two, but there's two general ones. One is SQL, structured query language. NoSQL doesn't mean it's not structured. What NoSQL means is it's not only SQL, and NoSQL tends to be quite popular in the IoT world for a number of reasons. But here are the major best known NoSQL databases. Here is the URL. It's a bit long. If you want information, email me. I'll send you the URL. Dynamodb is what Amazon offers, and it's proprietary. Although it's not got a huge write-up, I've found it really, it scales massively. The performance is absolutely fantastic. I like it a lot, obviously. I'm talking about it. Here are some others. I particularly like MongoDB. When you get into this, you have to rely on your technical people, but what I'd say is, if you're going to look at a NoSQL database, look at MongoDB very seriously. Again, I'm not rewarded by Mongo. I just happen to know a little bit about it, and it's very good. Management and support. So if you're starting to deliver service end to end, you have to think about these devices being in remote places, how do you change them, etc., and then your back end, etc. What do you have to think about here? So let's look at the cloud part first. So if you've got if you're moving into smart homes and you're an IT type company and you're familiar with computing and clouds, etc., then the cloud part is probably what you've got now. You've probably got staff that can do that, or you can outsource it to someone. It's fairly straightforward. It's not too difficult. What about the sensor part? Sensors and gateways type devices. Back to smart homes environment. It's in homes, blocks of flats. If you're an IT type company, IT type reseller, your existing processes are not likely to fit really well. It's not like upgrading laptops or managing laptops. And these devices, so these gateway type devices will usually not have an on-off switch, no power switch. They'll run years, 17 years. I've had something run 17 years in a dark place. No fans, no moving parts. Usually no fans to go wrong, no moving parts, and designed to run from maybe minus 40 degrees to plus 70 degrees ish, or minus 20 to plus 40. So it depends on your environment, but they will run for years in a dark place. That's why, by the way, patching and security upgrades or just feature upgrades is important. So remote device management. And then same for these. If you're running these in dark places in a block of flats or wherever it is, how do you go and change them when you've got problems? So think about how you actually track them as well. I've got customers that use GPS on these, so they've got huge deployments. And I've got customers that use these on boats, believe it or not. Remember I said about engine condition monitoring? I've got customers that have gateways in very large ships cruising around the world, and you don't have one gateway, you usually have a few of them, but when that sensor, when that ship comes into port somewhere, it connects up to the local cellular towers, etc., and says, I'm here. And that's important when you want information about the boat, the ship, the onboard systems, etc. The cost and disruption, health and safety of physically changing things. In the utility world, i.e. water, electricity, etc., it's almost always two men, a set of ladders and a van. So a simple change to a sensor that costs £40 might cost £500 in terms of manpower to actually go and do that. Questions. Now, I will try and answer all your questions as accurately as I can.
Hello, right. Thank you very much for that, Mike. We're now going to move on to the question and answer session. So if you have got any questions, please type them into the chat facility. So if you look up to, let me have a look that side of your screen, I think you'll see a little box with a question mark up there. So if you have any questions for Mike, please type them into that box and we'll get Mike to answer them. Thank you. Yanis, I think that you might have had a question for Mike. Do you want to ask it?
Yes, hi Mike. Would you like to say a few things more about the Smart City initiative and how this is related with what you mentioned to us about the whole system, that the whole IoT system you described to us?
Audio is not coming through very clear, Mike. I think you are off of mute, but I think you might need to put the volume up. Still very quiet there. If you can just bear with us for a little while, participants, and if you have got any questions, remember to type them into that that Q&A box there. I think we've still got a technical issue. This was always going to happen. I did say that we might get a hiccup here or two. We have got another question that's come in to Mike as well. So I don't know whether Mike, can you type an answer? I don't know what your typing's like. Can you type an answer into the text box for Yanis at all if we can't get audio?
Working now?
Yes,
I've lost Nigel now.
that's fine, Mike. I can hear you now. So yeah, we've got the first question that came in from Yanis. Yanis, do you want to repeat that question, and then we'll go through the other ones?
Actually, I have gone through the questions of the participants, and I can publish a couple of them if that's okay. I can see one. Can you see it, Mike? Recommendations for, I have a participant who asks recommendations for IoT edge gateways.
Hold on. A recommendation for specific gateways? Is that the question?
Recommendations for IoT edge gateways.
Yeah, that would be wrong because so I work for a manufacturer that does that, and they would probably love me to make those sort of recommendations. But it's what I would say to you is that most manufacturers' gateways are reasonable. And it's just not that simple. So the company I work for happens to be very strong in utilities, and I think what you're going to look at is your use case. So if you're looking at gateways for M-bus, meter bus, then research your requirements. Then search for IoT gateway manufacturers. Yes, the employer I work for is excellent, absolutely fantastic. So I work for Eurotech, but I've never done this before. I've not promoted Eurotech in any IET events. That'd be wrong. But some of the manufacturers are just not very good. So what I suggest is do your research, and the things that I put in the presentation about an open source Linux type gateway. Avoid lock-in with if it says, and I know this for a fact, a lot of them will say, this is a gateway that comes ready, packaged to work with this cloud. That's fine. That's absolutely fine if you understand that. Then you need to ask is, okay, if I can connect to that cloud, can I connect to others? And that's when you have a problem. Check for over-the-air upgrades. Can you upgrade the device over the air? That's really important. Check for the IDE, the Integrated Development Environment. So that should run something like Java, JavaScript, C++, something like that. And then check the physical box itself. What you get is some boxes are delivered, and if you want to install an antenna on it, you have to get a chisel out and knock a hole in it. They've got like I don't know what they're called, but little bits you punch out with something, and then you open the box and screw the antennas and things in. The better quality boxes, like my manufacturer, they come with everything pre-assembled, and you screw your antenna in. So look at the on-site information, avoiding lock-in, etc. They should have things like Ethernet connectivity, serial I/O, digital I/O, Wi-Fi, Bluetooth, check what version of Bluetooth you're going to get, check if it supports LoRa or not, check what the JVM, and that's important because Oracle's made some announcements about various JVMs, so check what licensing you've got on that. It's not that simple. The gateways is the most complicated part because you're connecting on one side to the devices or the sensors, and on the other side back to the cloud, and they're the key part. So where was the other questions? So so it's gateways is the important part. There's a question here from Ursel.
Yes.
Is engineering around vendor lock-in worth it? There's increased complexity around maintaining and running your own infrastructure, and what kind of industries use cases might it be worth it? So, okay, I personally would not try and avoid lock-in. I would go in with my eyes open and say, okay, I'm going to work with AWS, for instance. However, and I know this very, very well, utilities quite often build their own environment, and then there's commercial things. So what you have is, let's just say you use Microsoft for. So what you find in the engineering world is that the finance people will influence you. So I'll be conscious of my time, so tell me when I've spoken too much. So what you find is that the corporation uses Microsoft, and they're encouraged to use more Microsoft to get the discounts for the year, so they use Microsoft Azure. Or you get Google and you use Google services, same thing, use Google Cloud again, or use Oracle and use Oracle Cloud. So what I found in large operations, large organizations, is that it's generally not a solely a technical decision. It's much more governed as well by finance. And I agree with what Ursula said then about that, because I'm quite happy with AWS. I just mentioned that some companies do want to have the ability to get out. And I'm not going to mention it. One of the biggest firms in the world I was working with in London about 5 years ago, and they were locked into a big cloud company. And when the chap met me, he said, "Mike, for God's sake, don't tell anyone else you can unlock us from this," because they just spent X millions with a company, well, a big integrator, to get out of that cloud company. I'm careful what I say, because they're touchy subjects, locking and being able to get out. How am I doing for time? Because I know I wasted time on being disabled on voice.
You're fine for the moment. We've got probably another one question there, Mike.
Okay. What's the next question, please? If you can see it, could you read it out, please, Nigel?
Yeah, I got one here. Raja says, in a domestic situation, how would the sensor typically be powered?
Yeah, good, perfect. So the sensor should not be locally powered from anything in the house or the home. So it'd be the perfect way to do it is 2 wires, just 2 wires, and the 2 wires run back to that central concentrator, and that's where they get their power from. And that wire is typically, they say in theory, 350 meters before you get to a repeater, and you can have a total of, well, have as many repeaters as you want, I think, but the total distance from the home sensor to the concentrator, strictly speaking, is 1,000 meters, but it's actually really governed by capacitance and line resistance. But so they say 1,000 meters, but you'd have to have at least 2 repeaters in there, and just use 2 wires. You get the 2 the concentrator supplies plus 36 volts for a mark condition and plus 24 for a space condition. What that means is DC. What that means is each sensor typically draws 1.5 milliamps in the mark quiescent condition, and up to 20 milliamps in the space quiescent condition. And the reason I'm saying that is that's where we get the power from. The current draw from the current supply to the sensors comes from the concentrator. Sorry about that background. That's the door.
Well, that's probably, I know that's your delivery you've been waiting for, Mike.
Yeah.
So that's probably a good time to cut it there.
Cheers.
There's been, thank you very much for that, Mike.
There's
been some questions around, will these things be recorded? And the answer is yes, this session's been recorded and we will place it online. It may take a while, so don't expect it to pop up immediately. It might take a week or 2, so bear that in mind. Okay. Thank you very much again, Mike. Moving on now. So we're now into the next session. The next person up is, sorry, I'll just move the notes into the way there. The next session is Chris Barlow from the Data Communications Company, DCC. Chris is the Director of Innovation at the DCC and has 15 years experience as a multidisciplined IT professional specialising in high-profile initiatives and driving business transformation. He is a well-respected tech innovation communicator who possesses a rich understanding of all aspects of software and infrastructure development. This helps bring together technical nous alongside business insight and thought leadership. His experience and expertise in smart energy technology has led to the design and implementation of multiple large-scale implementation solutions, positively affecting millions of users. Now, you know, what's that all about? I think, well, Chris is going to tell you all about that right now. It will take the form of a a couple of video first of all, and then a live presentation, another video, and then at the end we'll have that standard Q&A again. So thank you very much, Chris, and over to you.
Hi, my name is Chris Barlow, and thank you for the opportunity to speak to you today. I'm going to talk through a bit about what DCC is and what we have available in our kind of rollout program, and what we're doing to help smart cities and basically move us into smarter, greener lives. So I'm just going to share a presentation here. Sorry, technical difficulties as always. Okay, so hopefully you can all see this. I'll take that as yes. Cool. Okay, so why smart meters? Okay, so you may be thinking, hopefully all you guys here are all thinking about, yes, there's a good cause for smart meters, but actually in terms of customers and consumers, they often wonder why we're doing it, and it's probably one of the main drivers we see is to try and reduce carbon output. And if you look at people who've actually used smart meters, and we have a lovely picture of an in-home display there, being available to see your consumption actually helps you reduce your consumption. So by flipping on a kettle, you know that it's using a certain amount of electricity, and therefore you might say, well, actually, do I need to boil the entire kettle, or do I need to boil the water I need? And that it kind of does relate to approximately about a 5% reduction in electricity usage or energy usage in total, but it also starts that conversation. It starts to get a consumer involved in their energy consumption, and that's a thing that we've been a bit detached from, really, if you think about it over the many years. And so smart meters is going to be rolling out to every home in the country, and that means that people will start to get more aware of their energy and also see the new propositions that energy companies will provide to them. And it's one of the last digitizing one of the last analog industries, really. If you look at what we've got left, from TV to broadband, etc., these are one of the last things that we've got on the roadmap to change over. So what does the DCC look like? So this is the ecosystem of DCC, and if we start over on the left hand side with energy consumers, that's you and I. That's our home. So in there we have in-home displays, or if you had a smart meter installed, of course, you'll have a in-home display. You may have gas, you'll most likely have electricity, and you can see there's a little cog at the bottom for smart appliances, and that's really leading on from Mike's previous presentation about gateways and routers and how sensors can be used in homes and in different locations. We have a communications hub that powers all of these things that we see here. So, well, by powers, it means makes connectivity happen. It does physically power. It is physically drawing power from electricity meters on the supply side, so you don't get billed as a consumer. But this comms hub or digital gateway, secure digital gateway, will be sitting in everyone's home, and we can see a future where you're using more and more sensors off of that, and actually being able to get some useful information pulled back through there, and actually be able to say that digital gateway is available as a product that people can use that's already installed in people's homes. And I think that's a really important point. You know, we're always talking about saving rare earth minerals and things like that when we're creating these products, and creating lots of plastic and things like that. Reuse of an asset that is going to be in people's homes, I think, is only a good thing to happen. So that's something we're working on. We're engaging with customers this year. We're really pushing forward and trying to bring along that journey of saying that this is a really good idea, and can we open up the system to do this. Moving on to the actual ecosystem itself, we have a bunch of partners that help us run this. We sit across the top, but we have a data provider, a data service provider in terms of CGI, and that would be what we'd traditionally call a head end. And we have a bunch of communications providers. We have some people who provide some specialist software for us in terms of critical software, and CapGem also providing some of the infrastructure that goes with that. Security is really key for us at DCC, excuse the pun, but we have this smart metering key infrastructure, and basically that is like a set of keys really that allows security to flow through the entire system. You may have heard of terms like end-to-end encryption and things like that, you know, using WhatsApp and things like that. This is kind of a similar principle that we as DCC can't see inside the packets that traverse our system. Okay, but we can secure it using this smart metering key infrastructure, allow us to pass information from point to point, and it only be unlocked by the person it's supposed to be seen by. And at the heart of that, it's run by BT for us. And we are an arm's length subsidiary of Capita, so that they provide our enterprise systems that support us. On the far end, obviously, we have far right hand side, sorry, we have our users, and they are typically energy suppliers, gas and network operators, and we have another category that we've authorized third parties, or what we've unimaginatively called other users, and they are people who can get information from the system, always with the consent of the consumer, I might add, that allows them to see stuff about, you know, offer products and services to those consumers, and you know, for data, for switching and things like that. Yeah, moving on. So just to give you some stats, I know everyone loves a few stats. So how's the rollout going? So we have 10 million meters on our smart metering network. This was taken as a cut from Friday, and you know that's an awful lot of meters. We actually want to get to about 35 million meters. Sorry, 50 million meters, between 35 and 50 million, but that will represent 30 million homes. Okay, so not every home has gas and electricity, and that's why there's a kind of ratio to how many meters we will have on there. We have 6.7 million SMETS2 meters, so that's the latest generation of meter. There was a SMETS 1, which is next to it, and that's at 3.5 million. And we do an awful lot of messaging. Okay, so we're 352 million messages were traversed our network in January, and that's only getting bigger. Every day we are installing roughly 11,000 meters onto our network, and I say roughly because it does depend on weather conditions and time of day, and weather conditions and availability of consumers, etc. But roughly that, and we're also migrating meters across as well. And yeah, our busiest data point was in October, and that had the record month of installing these smart meters. So how do we see ourselves transforming the energy system, and how does that work with this smart city concept? So being able to use more data to drive decisions, to drive efficiencies in local government is a great opportunity, right? If you're a stretched council who's got some limited amount of resource, who wants to focus on fuel poverty in homes that are poorly insulated, or might benefit from grants to have themselves, cavity wall insulation or loft insulation and things like that. You can actually use smart metering data to help you give a kind of indication of where you should be focusing your resources. So, looking at the amount of, say, prepayment top-ups, or looking at if you've got access to the consumer's consumption data, you can see how much they're actually using, and with what we've talked about, what I've indicated earlier around putting some sensors and stuff into a property, you might even be able to see the temperature and stuff like that, and those kind of things can loop together to give a really rich picture of places that would be in need of government assistance. We can also look at energy efficiency and low carbon heat as well. I think that's another thing that we can enable as a platform for offering these services. EV, obviously, next big thing. If you've ever had an EV and you've tried to charge it and you've gone around, you'll notice that there is a whole what I would call a fragmented system of charging through the UK, and it's basically because we don't have a kind of joined up approach on how to roll out EV. Much like when we rolled out the first generation of smart meters, it was a market driven event, and we ended up with lots of different pockets of functionality and lots of different non-interoperable devices, and it was a good exercise in getting the market to push forward, but didn't really create that kind of holistic joined up approach and kind of thing that kind of propositions that consumers expect. So a good example is that you drive a car at the moment, you go to a petrol station, you expect to be able to get petrol. You don't arrive at a petrol station and someone says to you, oh, actually no, what you need is a Ford GT, you can't use your Ford Fiesta here. That kind of thing, you don't want that. You want interoperable, you want complete freedom to know that if you rock up at a petrol station, you can take the petrol that they can offer at the price they're offering. And that's the same for EV, right? If you've got a car that needs to be charged, you don't want to be told that you've arrived at the wrong charger. And we certainly see ourselves being able to support EV in that and provide a platform that charge point operators can use that can link all of those charge points together, have an element of it, have that full interoperability, and then have an element of competing propositions. So there might be something that says, and we wouldn't get involved in the proposition. Don't want to make that clear. DC is more of an enablement to these things, but being able to offer a proposition that says, I'm an energy supplier. I can offer an EV tariff, and that EV tariff can be portable throughout the country and usable at every charge point. I mean, that would be a reasonable proposition, I think, for most people who've got EV cars, and that's something that we could definitely help with and hope we could be part of that enablement. Supporting new technologies and improve the grid. So part of DCC's users are what we call district system operators, and they are, or they used to be called district network operators, and they're the people who run the network essentially. So the Great Britain is broken up into a bunch of operators, and so in Western Power Distribution or people like those guys, or Scottish Power, for example, they would own different bits of the network, and they would obviously be interested in stuff like EV, right? So if you've got a whole bunch of EVs plugging in at the same time every night, that might be a problem for the grid. So having access to the DCC network and being able to see across that piece and seeing EV charges, or in fact just seeing consumption in general, is a real help. And they can do consumption at the moment. They can see consumption by going on and seeing who's using what and where. And I think an EV as a slice on top of that would be really useful, especially for our aspirations of carbon neutral and EV cars everywhere. So I've talked about some of the stuff that is in DCC today, and we have a national reach. We service more properties than BT does. We have a core network of cellular in the central and the south, and we have long range radio in the north. basically because in the north it's a bit more spread out geographically, and getting to those places is not very well served by cellular. Where we see to leverage that is on EV, so in-home charging, out-of-home charging, rapid charge point management, things like that. Because they're going to have 10 million EVs on the road by 2030, getting that technology right now means we will be in that correct position for the future. And where we see ourselves working more in the future, potential is around air source heat pumps and battery management. And this is all all part of one holistic network that covers Great Britain. Smart cities, smarter future. So if you can see, smart street lamps, I think are something that we could definitely be part of, and our network could support. Flexible energy systems, how that enables us to be cognizant of the draw on our network and making sure that we do keep the lights on. We don't want to end up in a situation like other countries where they experience brownouts and blackouts and lack of energy resource. Environmental sensing. I think this is, for me, is a really key point. Is how can we look at making sure that our environment is conducive to good health, is a good environment to raise children, etc., and we're all experiencing quality of air and those good things, and that's something we're really passionate about, is those smarter, greener lives agenda. Heat pumps, we have a massive push for decarbonisation in the UK, so in Great Britain. So being able to have heat pumps rolled out, and as a government aspiration to get more heat pumps out there, can only help with that. EV charging I've already spoken about, but it's part of what we see as that smarter future. Being able to secure those digital those charge points, it's because of that fragmented system. You don't always have the same amount of security provision on those networks. So we feel that DCC, as the way, why we're so centralized on security, we can offer those services so charge point operators don't need to learn that again or make the mistakes of previous generations. Smart water metering, it's something that has been bubbling around for a while. It's certainly something we're interested in, and we're looking at, we're talking to people who come to us and talked about smart water metering and how it might be effective, and we're certainly open to those conversations. On the back of that, data insights into that, we offer a service in DCC called our Technical Operations Centre, or the TOC for short, and that produces a whole bunch of reports for our customers on how they do installations and general technical bits of information. Like I showed you the figures earlier on, that's come from our Technical Operations Centre. So we've got a good handle on how we could do data insights, and of course that would apply to smart water metering. Leak detection, obviously a big one. I live in the south and we don't have a great pipe work, and leak detection is also in the home and out of home. So yeah, that's something we could definitely see ourselves being able to offer as part of the, when I say we offering as DCC, I'm talking about enabling a platform that could offer that. We ourselves would not actually offer those services. That's something that we leave up to the industry, but what we're seeing is how we can reuse this great asset that we have that's being installed in Great Britain, and how we can best reuse that to actually provide some value back to everyone. And smart digital healthcare and well-being. Now, we're not looking to get into hospitals and things like that, but there's a whole bunch of stuff around patient monitoring, alerts for in the home. Someone trips or falls over and they can push a button and get help arrive to them, and some of these services run on some very archaic technology, certainly stuff that's being sunsetted in the next 5 to 10 years. So the digitalization of that, what do you choose? Do you go again do things that are out in the that have been out there for a while, or do you and have individuals produce different pockets of functionality, or do you have something that you can say, well, this is a standard platform that we can build something off of that we know will work interoperable throughout the UK. temperature humidity sensor, already spoken about this. You know, that's a really key indicator, and I know Salford's doing a lot of work in that area around respiratory health and things like that. So that's definitely something we could see the platform enabling. And being able to provide behavioural insights. I know there's some great work that's been done by Liverpool John Moores around dementia patient monitoring through the consumption data. So yeah, that's something that we could help with. You know, we have the technology to move that consumption data around, and using us means it's going to be ultra secure. So, and the final one was, using data to support vulnerable customers and identify fuel poverty, which I've spoken about before. So that's a quick run through of the things we're doing. What I wanted to show you is something a bit different that we've been working on in DCC. We have a bunch of internal tools for our own understanding, for our own testing, and we've been working with customers to try and work out how we can package those up and make them available to wider communities or to our customer communities, and so they can do better testing, more experimentation, things like that. We colloquially call it DC Boxed, and that what it contains is a representative end-to-end system for DCC. And what I'm going to show you next is a video on that, which is the digital dashboard we've got. It's a 7-minute video which just runs through some of the key bits of functionality we have, and it was just to show how that might work. So I will stop presenting and we'll have a look at that video. So this is the homepage of DC Boxed. We've laid out 3 cards here which show the gateway, which is DC user interface, Mckean, which is how we get certificates and things like that, and devices that show all the devices that are on the system as it stands. So essentially, when you add a new communications hub or a new electricity meter or gas meter, they will appear at the bottom here, and that will count for both emulated and real devices. So this is our DC user interface. What we've done here is selected a select number of service requests that we can just basically, for the purpose of testing, show against devices. You can select user roles and generate those service requests. Now, the product itself will support the majority of service requests, and you'll be able to launch those through the API interface that we have. But for this graphical version, we just support a limited subset, so people can understand and get used to it. So here we're doing a read inventory. Submit request, it goes up to the device, and here you can see the responses come back, and these responses are formatted exactly as they would be on the DC user interface itself. We can restart the service request and send another one through. This one is send a read firmware request, send that out to the device. It's worth pointing out this is a dual part or an asynchronous request. So you see here that we said that this is a synchronous response, but there is an asynchronous response that will contain more, and that can be viewed through the log function that we have at the top there, gateway logs. So this is our hand page. It shows you the devices we have in the system at the moment. So one big difference between us and GFI is that we can support multiple hands. So if we look down here, you can see there's a bunch of comms hubs, and they have both physical and emulated devices against them. So this is another key point that we were able to mix and match our devices. Being able to support multiple hands means we can support multiple test cases and things like that, which is great. So, but we can actually look at devices which don't have comms hubs. So we have a lot of devices in here. Obviously, they've not been commissioned against comms hubs, and it's just a really good way of keeping track of all the things that we have. And if we had any handheld terminals, they'd appear at the bottom here. As you can see at the top, you might have noticed that things says sniffers. This functionality will allow us to actually look at the traffic that's occurring across GPCS and Zigbee, but we haven't implemented that yet. So I'm going to take you through our devices pages now. So these are on emulated devices. This is a ESME. It's in prepayment mode. It's got active tariff. You can see some consumption information there. We can do load simulation on devices. Auxiliary controllers are in there. And of course, Zigbee network. All these emulators run on a real physical Zigbee network, so we're able to see joint, etc. We have some simple commands on the top here, so we can generate alerts, restart the devices by shutting them down, and see the clock to get those to send commands down to the device. We also have some more complex commands that we can send. For example, I'm just going to scroll down to load simulation. We can build out a load simulation template here of several lines and power factors and seconds they need to run, and we can apply that to the device and see what the results and actions are. It's worth pointing out for all of our emulated devices will have different functionality, obviously, and that will allow, this page will show us different variables and things that we could actually do with the devices themselves. Here we are at our Smart Metering Key Infrastructure portal, or SMIKI for short. This portal allows us to generate certificates that will be used when DC boxed. We can generate them for organizations or for devices, but we start off by putting a certificate signing request into here, and we choose what we want to do, in this case a device. We are then able to generate that certificate, which is essentially a certificate signing request. And you see here the certificate's generated off the back of that. We can download it. Automatically, these certificates are stored in the repository, and we'll look at that in a bit. We can download them. We can also use this functionality to upload certificate signing requests, because they can be generated elsewhere, and actually, rather than typing in and pasting, we can do that. You can see it has the same effect. So here we are at our SMIKI repository. This allows us to search for certificates. It allows us to view them and actually download them. So if we go ahead and search for a certificate here, see it shows all the ones that we have in the system, and we're able to download those, or we've got a brief synopsis here of what they are. But if we download one, you can actually see the structures conform to what I would say is production certificates. Obviously can't be used in production because they are generated within DC boxed. But you can see here they have subject, issuer, serial number, valid to and from dates, public keys, all that good stuff. So here we can see all the search functionality. So you can just search through and you can see when we have find certificates, then I'm showing. Very simple. So here I'm going to show you some of the help functionality. So on the web pages we have an inbuilt help function which allows you to contextually say that if I'm doing something, I can click the help button and it will give you some contextual information about what you're actually planning to do. In this case, we're talking about certificates, so when you click the help, you get some information on certificates. And this will be throughout the system. There'll be various help buttons available. So this is the home page.
Thank you very much there, Chris, for your presentation and the two videos there showing what DCC do. Certainly I find sort of what DCC are doing now, sort of from someone that was just providing that infrastructure of part of the smart meter, into really developing some exciting potential for developers in the commercial world there. We have got around about half an hour now for questions, so if anyone has got any questions for Chris, please type them into the Q&A box, which is that, got to get the thing right, not that side, up in your thing, the little question mark up there. So leave it a couple of minutes. got one question. What is the carbon footprint of the data sent across the network? Do you have any idea about that, Chris?
The carbon footprint of how many, what? So the how much is generated by, you know, consumption on the network? Is that what you mean?
I think that is for the data going across it. Yeah.
That's not a question I've been asked before, actually, if I'm totally honest with you. We do know that the IHDs in the home provide a carbon footprint of energy consumption to the consumer directly. But yes, the problem we have is we don't see consumption data. So as an energy provider, you could take that consumption data and provide that calculation across your entire estate and things like that. That's totally possible. So yeah, I don't really have much more I can say on that, I'm afraid. We don't access consumption data, so we don't get to see that information, but consumers definitely can in the home.
Keep on typing away. We will read anything out as it comes across. Yanis, you're always the type of person that you've got a question to ask. Got to unmute yourself first, Yanis.
Hi, Chris. I would like to repeat a similar question like with Mike. If you could say a few more things about how DCC will assist the very, very big initiative and project of the smart cities.
Yeah, absolutely. So we see ourselves very much as an enablement service for our customers, right? And so being able to be that platform that they can come and use and leverage for doing stuff like EV, I think that's a key thing that we've spoken to our customers about, and certainly government is pushing us in that direction to look at how we might provide an EV charging platform. But I'm intrigued in all the other stuff that we can do to kind of leverage that IoT style gateway, that, you know, the communications hub that's going to be in everyone's home. So being able to put stuff on there to, like I said, for being able to show how you can add simple sensoring like temperature and humidity to a property, that would be really useful for improving people's lives in, say, the social sector, or even just as a normal consumer understanding, you know, is my home damp? Is it am I overheating? You know, that kind of stuff. We definitely see a future for it, and can see some really good benefit, and, you know, and to get into our core principle of helping people live smarter, greener lives, that can link into there. I also think out of the home is just as important. So being able to potentially leverage our communications network to provide communication to some of those IoT devices that might be out doing smart street lampposts, or in fact just doing anything out of the home. I think that where we see ourselves is the enablement platform. People are going to come up with the fantastical ideas that work off of it. We're just going to be there to provide the nuts and bolts, and I'm very happy that we could do that. So I think that's where we'll be helping in that industry, is providing platform for growth and innovation, and so that we can reuse those assets that are being installed.
One more question, Chris. There's Match2 generation provides information about the reactive power.
Yes.
Would you like to say a few more things about it? In relation to the to the PV installations, etc.
Right. Okay. So yeah, I mean the kind of same technology we're using for the what we call ESMEs, or electric meters, is going to be contained, can be packaged up for use in, say, a EV home charger, right? So you could have in there, they're sometimes called proportional load controls, or standalone proportional load controllers, auxiliary load controls, so SAPC. I never use the full term because we always work in acronyms. But you know, those kind of devices would sit inside, say, an EV charger, be able to provide demand side response and load and reactive load control. And those power measurements can be read by both the supplier of that charge point. They can be read by network operators as well. So balancing off that network and understanding what that looks like on those charge points is is really useful information, and it's not something that's readily available at the moment. So I think that's something that we have the technology ready for. We just need people to use it, really.
Yeah, we have a few more questions. One question is from Luis. Luis asks what access is available for a developer to test smart meter consumption on a home device. Are there any APIs available?
Right. Okay. Yeah. So as it stands, no. We're certainly going to take our customers on a journey this year to start looking at how we might be offering more advanced testing services that we could potentially charge for, or if you were to become what we call a SEC party. So that all the people who work with DCC are generally a party to the Smart Energy Code, or the SEC. And it's not an onerous thing to do. You know, you sign some forms and you signed up some terms and conditions. But getting into that, then you can start to use, start to come to our events and understand what we're doing, and have access to products and services that you might not have as an outsider. But yes, the future is in having API access, having tools which enable developers to innovate and kind of demystifying what the smart metering system is and how it can be used. So watch this space is what I'd say.
I would like to also to respond to Luis that on Thursdays and Tuesday sessions we are going to talk about consumer access devices, external actually consumer access devices that someone can pair this extra hardware with a domestic smart metering system, both electricity and gas, and access their data through the cloud, through a cloud service using API technology. And in one of the sessions that Nigel and I have prepared, using such a device, you will be able to access the electricity and smart meter of the smart meter lab. That will take place, if I'm not wrong, Nigel, I think next Tuesday, isn't it?
Yeah, I think it's Tuesday, yeah.
And on top of us, it will be on Thursday, it will be Josh from Hildebrand that focuses on consumer access devices. So is this kind of technology, and data can be accessed with up to 10-second granularity, which is it's a very high granularity for various applications. So Luis, wait for the next session and the session on Tuesday, and we are going to discuss about this. Another question is, does DCC get involved in private wired networks?
Does it get involved in private wire? What, in the provision of or the use of? I mean, we have wired. So some of our connections we use a private network called Gamma, which provides some of the connections into DCC, but we ourselves don't offer a network.
Going on to that, Lewis, I mean, with the private wire network, what about a independent IDNO, an independent district network operator? Would you offer the same service as you offer the existing DNOs? Would you offer that to an IDNO over a larger private wire network?
So all of our customers, their connections to DCC are provided by this Gamma network. So if they've gone through the onboarding process and become a user of the DCC, that's how they would connect. So yes.
There is another question. Would it be possible to collaborate with Smart Energy to do a demonstrator project via applying for EU funding?
I am always up for a discussion about how we might be doing stuff. So yes, I mean, I think having a look at what we can offer and what we can work on is definitely something we're always interested in having those discussions about. There might be some particular ways the way we're set up that we're not able to do things on every opportunity that comes up. But yeah, certainly let's have a discussion.
So you may be able to exchange emails and. Okay, there is another question here. Oh, I lost it. Yeah, is it possible to build upon your infrastructure to offer a general purpose IoT infrastructure and offer it as a PaaS? PaaS, I suppose, is platform as a service.
Yeah. So that's part of the discussions we're having with our customers over the coming months, is that being able to offer access to that communications hub or that digital gateway would provide a system that is like an IoT system that can be used as a wholesale product. So we as DCC are not the gatekeepers for specific people joining, but more like BT Openreach offers their pipes and fibers out to people to use. That's definitely how we could see DCC operating potentially in the future. So yeah, that's something we are actively talking about. Well, we'll be actively talking to our customers over the coming months.
Cannot see any new questions. Nigel, would you like to?
Yeah, it's well, I've not got any more questions. It will, if someone wants to type one in the next few minutes, we'll continue. Like saying, we got up to 3:30. Otherwise, we can do a wrapping up. It's entirely up to people. We are here for you. So yeah, give you a couple of minutes if you've got any more questions for Chris, or I think Mike has gone, unfortunately. But any more questions for Chris, please type them into the Q&A box.
I would like to add something. I have worked with Chris in the past about, Chris briefly mentioned that, about a HumiTemp device that measures the temperature and humidity inside the house, which is a very, very interesting tool for various building environment projects. For example, to measure the heat transfer coefficient, which is very important for the buildings. And I think that these additional products, well, the core and the heart of everything is the smart metering data, but of course these additional data streams will make a huge difference, I believe, in the future.
We've not got any more questions in, so like I suppose like the auctioneer, I'll ask him once, ask him twice, ask him for a third and last time. Okay, right, we'll formally close this session down. Just like to thank again Mike and Chris for their useful insights into the smart homes ecosystem. I'd also like to thank, you can't see, but behind the scenes are our people, Ben and Alex. They're doing a lot of the jiggery pokery over there, so thank you very much, you guys.
Nigel, may I interrupt you? There is one more question.
Okay. Well, let me finish this off first,
yes,
and then we can do the last question. So we've had a few hiccups, which is great. We've had a couple, but you know it's going to happen. What I will do is people have asked that by tomorrow I will email everyone again with just the links there, and I'd also put a written URL for the meeting room, so you don't have to sit there laboriously and type them in. And the very last question from Raj is how do smart meters actually communicate back? Does it have a dedicated radio link, or 3G or 4G or something else?
Yeah, okay, great question. So the communications hub is what sits in it will sit in a home, and actually I've got one here. There we go. It looks like this. Oh, the wonders of a white product with a digital background. There you go. So that's actually a communications hub, and it's basically like a modem. Okay, and it provides a local area network, or a home area network, a HAN in the home, and it also then connects wirelessly to a WAN, so to a wide area network, either through long range radio if you're in the north and Scotland, or if you're in the central and south regions of Great Britain, you will be on a cellular solution. So that's a 2G, 3G connection.
Thank you very much. So I will, yes, formally bring today's session to a close. We will see you back tomorrow. Like I say, and I'll drop you an email with those links on there. So tomorrow we have Josh Cooper from Hildebrand talking about accessing smart meter data using a consumer access device, and also we have Carolus from Evergreen Energy talking about optimizing energy savings using time of use tariffs, specifically in this case on a heat pump. So really interesting.
It's Nigel, just a small thing. It's not tomorrow, it's Thursday.
Thursday, yes. Sorry about that, Thursday.
No problem.
Yeah. Thank you very much, and all have a good evening, wherever you may be.